Hello student, welcome to the course Control System. Name of topic Mathematical Modeling of Control System. I am Professor Vibhagon from Department of Electronics and Communication Engineering at Tulsi Ramji Gaikwad Patil College of Engineering and Technologies. These are the outline. What is the mathematical modeling? Why mathematical modeling is required? Step in mathematical modeling and mathematical modeling of mechanical system is two type: linear mechanical system and rotational mechanical system. And mathematical modeling of electrical system. Mathematical modeling, what is the mathematical modeling? Mathematical modeling is the process of representing a physical system using mathematical equations to analyze, predict and control its behavior. The control system can be represented with a set of mathematical equations known as mathematical model. These models are useful for analysis and design of control system. Analysis of control system means finding the output when we know the input, and mathematical model design of control system means finding the mathematical model when we know the input and the output. Why mathematical model is required? Successful in many further applications is give precision and direction of problem solution, allow the efficiency use of modern computing capabilities, prepare the way for better and design or control of a system. Steps in mathematical modeling. Identify the input. Identify the system: mechanical, electrical, thermal, hydraulic, etc. And identify input and output. Input: excitation applied to the system, and output: desired response of the system. Then applying physical law. In mechanical system, use Newton's law, and in electrical system using Kirchhoff laws. Development differential equations. Represent system dynamic mathematicals. And fifth, obtain transfer function. Transfer function equal to output and input. Six, analyze and design the control system. Mathematical modeling of mechanical system. There are two types of mechanical system. First is the linear mechanical system, and second is the rotational mechanical system. Linear mechanical system. A linear mechanical system is a system in which motion takes place in a straight line and the relationship between the force and displacement is linear. That is, it's obey the principle of superposition. In linear mechanical types of system, we have three variables: force represented by F, velocity represented by V, linear displacement represented by X. And also we have three parameter: mass represented by M, the coefficient of viscous friction represented by V, the spring constant represented by K. Linear mechanical system. In this figure, show the linear mechanical system, and in this figure force F is applied toward the right side. The mass M starts moving and displacement become X, while moving damper B oppose the motions and produce the damping force, and spring K compresses creates storing force. According to Newton's second law, we get this equations. F of t equal to m d square x of t upon dt square plus b d x of t upon dt plus k of x upon x of t. This is the transfer function of linear mechanical system. X of x upon f of x equal to 1 upon ms square plus b s plus k. Application of linear mechanical system. There are many applications of linear mechanical system. First is the automobile suspension system, using spring dampers and masses to absorb road shock, reduce vibrations, and improve passenger comfort and vehicle stability. Then elevator system uses controller linear motion to move the elevator combine smoothly and safely between different floor. Railway suspension system reduce vibration and impact between the train wheels and coach body, ensuring passenger comfort and track safely. Loudspeaker cone motions convert electrical signal into linear back and forth movement of the speaker cone to produce sound wave. Robotic linear actuators provide precise linear motion for robotics arm and automated machine used in positioning, lifting, pushing and pulling operations. Rotational mechanical system. Rotational mechanical system is a mechanical system which is motion occurs in the form of angular displacement, means rotation, rather than linear displacement. Variables of rotational mechanical system: torque represented by T, angular velocity represented by omega, and angular displacement represented by theta. And parameters of rotational mechanical system: moment of inertia represented by J, rotational friction coefficient represented by B, and spring constant K. Rotational mechanical system. These figures show the rotational mechanical system. In this figure, torque tau of T is applied to rotating the body. The cylindrical start rotating and produce angular displacement theta of T. During rotations, inertia J resist change in rotations and damper B oppose angular motion due to frictions and produce damping torque. Rotational mechanical system. Applying second law for rotational motion. So we get this equation: T equal to J d square theta upon dt square plus B d theta upon dt plus K of theta. Taking the Laplace transform in this equation, we get this equation, and this is the transfer function of rotational mechanical system. Theta of S upon T upon T of S equal to 1 upon Js square plus Bs plus K. This is the transfer function of rotational mechanical system. Applications of rotational mechanical system. DC motor used to control the speed and motions of rotating shaft in industrial machine. Robotics arms joint for precise angular movement and positioning of robot. Links in manufacturing and surgical robot. Antenna positioning system used to accurately rotated antenna for tracking satellite, radar target and communication signal. Servo control system used for high precision control of angular position, speed, torque in CNC machines and automation equipment. Aircraft automobile string mechanism used to control the angular movement of radar, elevators, and air laws for stable fighting and manufacturing. Mathematical modeling of electrical. An electrical system can be mathematical modeled using Kirchhoff laws and represented by differential equation and transfer function. The basic electrical elements: resistance, it's oppose the current flow; inductance, it's store magnetic energy; and capacitance, store electric energy. Electrical elements equation: resist according to Ohm's law V equal to Ri, and this is for inductor. This was the capacitor, V equal to 1 upon C integral I of dt. RLC series circuit. RLC series, in this diagram shown RLC series circuit. This is an RLC circuit. In this circuit, resistor, inductor, and capacitor are connected in a series, so the same current I flow through all components. Mathematical modeling of electrical system. Applying Kirchhoff's voltage law, V of T equal to V R plus VL plus VC. Substituting elements equation, we get these equations, and differentiating dV T upon dt equal to R di upon dt plus L d square I upon dt square plus I upon C. Transfer function. This is the transfer function of electrical system, and therefore taking the Laplace transform in these equations, so we get the transfer function of series RLC circuit. This is the transfer function of series RLC circuit. Applications: DC power system, and used for analyze, control, and stability, improve of electrical generation, transmission, and distribution network. Electronic filters, used to remove unwanted frequencies and improve signal qualities in electronic circuit. Communication system, used for signal processing, modulation, transmission, and distribution of information over communication channel. Robotics and automation, used to control sensor, actuator, and robotics movement for precise and automated operation. Electrical drives, used to control the speed and torque of electric motor in industrial machinery, elevators, and convey systems. Thank you, student.